Hey guys, it's Dr. Conklin and
Miss Bella.
We're super excited to do notes today for you on page 12 to 14 in our brand new Rigid Motions packet. Woohoo!
So exciting.
So exciting. So we're going to start, all the questions today are going to look like this. Here are our pre-image points. Oops, I got a little C left over. What we're going to do is we're going to use this coordinate rule. So the coordinate rule tells us how to move. We're going to take away 5 from the x and add 3 to the y. So there's a couple ways to do this. You can sort of do it by hand. I could do 1 minus 5 and negative 4, since that's my y value, plus 3. When I do that, I'm going to be left with negative 4, negative 1. So let's just plot that right away. 1, 2, 3, 4. Okay, so that's going to be my a prime. And I put that little prime so that I'll know it's the new point. We're going to do the same thing for b. I'm going to add 5 and, oh, careful, I'm not adding 5. Miss Vala, I almost had a mistake there. I'm going to take away 5 and add 3. So negative 3, comma 2. So let's check. Negative 3, 2. Ooh, that looks nice. Can you guys see already how AB looks the same as A prime, B prime? Oh yeah, Miss Val, we got this. No prob. I'm going to take away 5 here and add 3 here to get C prime. So I'm left with 1, negative 1. And that's C prime. And now I'm going to make this into a triangle.
That looks beautiful.
Interesting. Oh, well, thank you. What do we notice about these two shapes, though? They are congruent. So this transformation tape is basically a slide. What we did is we started with our original and we just moved it over. Make sure my points line up again. So this is called a translation. And is this a rigid motion or an isometry? It is, because the shapes are congruent. Okay, Miss Vala, to you. You got this. You got
right.
Alicia Keys and I are here with you.
I do have Alicia Keys here today. It's pretty great. All right, so this time, again, we have those pre-image points that we're going to use, but I want you to take a look at our coordinate rule this time. The only thing we're going to have to do is make our x values negative. So I'm going to start by writing down what my x values are here in the spot for my image points. 1, 2, 6. But I have to change the sign of them. So since all of them are positive, I'm going to make them negatives. Now, just to make sure, if, say, in this one, it was a negative 1, I would change it from a negative to a positive. So this negative, it's changing the sign. And now our y values are going to stay exactly the same. So I'm going to keep it negative 4, negative 1, and negative 4. And now we're going to go through same thing and plot those points now on our graph to see what that did to our triangle. So we're going to go to negative 1 down negative 4. 1, 2, 3, 4. And that's going to be our A prime. Our B prime, we're going to go negative 2 down 1. And last but not least, C was negative 6. And then down to negative 4. And that is our C prime. So when we connect this triangle, what I want you to notice here is this looks like almost as if this was mirrored over this line right here, our y-axis. So what was the name for this? This was a reflection.
Ooh, that sounds like an important word in geometry.
It is an important word. And the other thing, since it's a reflection over the y-axis, I'm going to say reflection over y-axis. And is this a rigid motion? Our answer, or isometry, the answer is yes.
Beautiful. All right, we're going to do 2 more with you guys, and then we're going to have you try a couple on your own. So this is a little bit sneakier one, because look at our coordinate rule here. Not only are we making the x negative, but we're also flipping these. So one hint is what I like to do is sort of make a middle step here. Like Miss Vala did, we're going to make all these negative. So what I'm going to do is I'm going to make this into -1, -4, -2, -1, -6, -4. Now I'm not done because I still have to flip them. So once you negate all the x values, now let's flip-a-roo. -4, -1, -1, -2, -4, -6. And then let's plot these guys. 1, 2, 3, 4. Down. Oh, I didn't warm up, you can tell. It's really hard, Miss Val, being a singing professional and a math teacher.
I was gonna say, because all the talking, that could hurt your voice.
Yeah, I gotta warm up a little better next time. That's okay, All right, so let's connect A prime, B prime, C prime. And let's take a second and just look at this. Does this triangle look like it's the same as this triangle? It does. And how does it look different? Well, it almost looks like if it was like a wheel and I was sort of spinning it around. It looks like I took and, wait for Miss Vala, rotated, or a rotation, I rotated this triangle about the origin. Okay, and if you look, since we said these shapes do look the same, this is an isometry, aka a rigid motion. Miss Vala, back to you.
All right, so for this one, notice again we have our pre-image points. And this time our rule, our x value stays the same, but our y value, it says 3y. So we're going to have to multiply by 3. So I'm going to write down our a values. Our x values, they stay the same.
Miss Val, I know what you meant. You got this.
And then our y values, I'm going to multiply all of those by 3. So -1 times 3, -3. 2 times 3 is 6. And -1 times 3, -3. So now when we plot these, let's take a look at what this does to our shape. So I'm going to go -5, -3. And don't forget to label them. So this was our A prime. This is our B prime. All of a sudden, I'm noticing this shape might look very different from our original triangle. And then we have 0, -3. So now when you take a look at this triangle,
Oh, it's so beautiful.
something's different about it. Any idea what that could be?
Doesn't look the same, I'll tell you that.
So it doesn't look the same. So it's not an isometry or rigid motion. And the name for this type of transformation is what's known as a dilation.
So, I think since we've done 4 examples pretty thoroughly with you guys, I think we're in a pretty good spot. But let's just review really quick. Sorry. We had 4 super important terms today that we talked about. A translation, which is also a slide. A reflection, which is sort of like a flip. A rotation, which is a turn. And a dilation. So I want you to think for 1 second. Which one of these is not like the other? Miss Vala. Which one of these would we say was a little bit different? I mean, they're all special in their own ways. We're not judging them.
They are, but wasn't the dilation, I mean, that's the only one that the shape doesn't look the same.
I wonder if that's going to be important in our future lessons. Wink, wink. It's going to be very important. So a translation, reflection, rotation, those are all rigid motions, always. But a dilation is going to be the only one that's not. So what we're going to ask you guys to do is you can sort of zoom right by page 13, unless you'd like, for some extra fun, to do page 13.
It's always an option.
It's always a great choice. We are going to ask you to do page 14, and I'm going to, if you need to take a picture of it, we're going to ask you to do page 14 for homework. You are not going to use this column here. We think it's actually better for you to practice by putting your graphs right on where the pre-image is, so you have your pre-image and image together. And I will give you guys one hint with this. You have a 0.5 here, so make sure here you're multiplying by either 0.5 or a half. Any other hints to add, Miss Falla? This one's sort of hard. Maybe we should not have them do F.
That can be a little
Yeah, you know what,
tricky,
guys? Hold on. We're going to have you do, is that too little homework? Yeah, and then we can have them do these 3, because I think if you guys are good listeners to the Ed Puzzle, if you can do these 3, you're going to be in great shape.
I agree.
Okay, well, we hope you guys have a great day.
And enjoy your... They have a long weekend coming up, don't they?
Well, you just got over your long weekend, right? Or no, yeah, you do have a long
Yeah,
weekend
you have a
coming
long
up.
weekend
Oh,
coming up.
enjoy, guys. Miss Val and I are. All right, we hope you guys have a great day, and we will talk to you soon. Bye.